Hello, thank you for joining me today at John Galt Solutions. My name is Barry Keating, Professor of Finance at the University of Notre Dame, as well as one of the co-authors of the book, Business Forecasting with ForecastX. In this segment, I'll be discussing how to run a Winters Exponential Smoothing model using the ForecastX Wizard. Running a Winters Exponential Smoothing model is essentially the same as running a simple or a Holtz exponential smoothing model. The difference is there will be three smoothing constants estimated in a Winters model. One will be the level smoothing constant, one will be a trend smoothing constant, and the new smoothing constant will be one that takes into account seasonality. Winters exponential smoothing, sometimes called Holt-Winters exponential smoothing, is actually for data that has trend and seasonality. It's probably the most often used of the exponential smoothing models. So now we have a model that can adjust for both trend and seasonality. We'll use a real data set. We want to take a look at light truck production in the United States. You'll see a graph of light truck production in front of you, and over the period of time for which we have the data, you'll notice that the trend is a gently upward trend, going from lower left to upper right. But you'll also notice that along with the trend, there's a high degree of seasonality. Now notice that this data is quarterly. So the months on the left-hand side of the screen are offset by 3 months at a time, which is the way that you show quarterly data in Excel. I'm going to begin the forecast by putting the cursor in the upper left-hand corner and calling the ForecastX dialog box. You'll notice that the ForecastX Wizard has correctly identified the data as quarterly, and it's also identified that there's one label at the top. That is the first row where it says date and trucks. The forecast period default is 12, and I'm going to leave the default as is. In the Forecast Methods tab, what I want to ask for is the Holt-Winters model. As we've seen before, we're presented with boxes within which you'd put the level smoothing constant, the seasonal smoothing constant, and the trend smoothing constant. But once again, don't put in your values for the smoothing constants. Unclick the Edit Parameters box and let the ForecastX Wizard pick the smoothing constants. You'll also notice that there's going to be an adjustment for seasonality that will either be multiplicative or additive. Once again, you need not pick one or the other. Let the ForecastX Wizard pick the best one, the optimal one, the one that gives you the lowest mean absolute percentage error. I've already selected the correct statistics that I'd like to look at in the Statistics tab and the report in the Reports tab. I'll be using the Audit Trail report. So I'll click Finish to generate the actual forecast. The Wizard has generated the forecast, and we can see that the blue line in the chart is the actual set of values for light truck production in the United States. The green line is the set of fitted values. Those are the forecasts within the historic period for light truck production. Once we get to the end of the historical data set, where the cursor is now, you'll notice that the red line that trails off into the future are the actual forecasts that we asked for. And notice that the red line correctly matches not only the trend in this particular data, but it also matches what appears to be the seasonality in this data. Directly underneath the diagram are the actual forecasts that ForecastX has generated in the future period. But if we page further down, you'll also note that the ForecastX Wizard has given us the original data, the fitted data, those are the forecasts in the historic period. The differences between the original data and the fitted data, those are the errors. And paging down a bit further, we can see the accuracy statistics. The mean absolute percentage error on this actual data set is only 6.37%. Looked at another way, the root mean square error, also an error measure, is only 29.39. The root mean square error is in the units of the item that you're forecasting. You'll notice that in the method statistics, we can see that we used a Holt-Winters exponential smoothing model, and you'll see all three of the smoothing constants given. In addition, we're told the particular type of decomposition that was used to calculate the seasonality. There's one extra table in the Holt-Winters exponential smoothing model, and that involves the seasonal indices. If we're given a multiplicative type of decomposition, these numbers will be slightly above 1 or slightly below 1. And they tell us exactly what type of seasonality occurred in each quarter of the year. On average, in quarter 1, this would be the first quarter that we would find in our data set, is a 4% above average month. The average are the 4 quarters added together divided by 4. On the other hand, it turns out the second quarter is a 9% above average quarter, the third quarter is an 8% below average quarter, and the fourth quarter is a 5% below average quarter. Since the first quarter in our data set was actually the first quarter of the calendar year, 1.04 indicates that January, February, and March quarter is a 4% above average quarter, but that most trucks, at least in a seasonal sense, are bought in the second quarter, and that's a 9% above average quarter. And that's how to run a Winters exponential smoothing model with the ForecastX Wizard.